Tabii canım. Bak şimdi oluyor. Şunu bir başlasana nasıl başlıyorsa. Burada bak.
Good afternoon. I have your attention. Do you have forms because of today? temperature or exact and optimization for reliable server physical systems.
Thank you. Maybe someone can close the door so that we don't have any noise. Okay, so thank you for coming to the session. 12 minutes. Okay, the session chair just reminds me that I have only 12 minutes, so I have to speak fast. Okay, don't worry about it. So, since we have quite a large audience today, audience with a wide spectrum of features, I will focus more on talking about maybe the motivation of this work and the background. So I will really talk about cyber physical systems, and then also, of course, the temperature impact, and then talk about the optimization technique. Okay, so this is one example of a hybrid physical system. A cyber physical systems is used to control many different functionalities. In this particular case, we are using automotive electronics as an example. In an advanced car nowadays, you might have 100 microprocessors, which are used to control different functionalities, like the engine, the transmission systems, the battery systems, and of course, a cyber physical system communicate, for example, in this case, with satellites for navigation information, with other cars, for example, in the case of automotive driving, of course, also with now the internet. And finally, we are talking about eventually the human being. We are being replaced by the artificial intelligence systems. All of such functionality are typically mapped on a heterogeneous hardware platform, meaning that we have, for example, microprocessors. Some of them have even dedicated hardware, such as FPGA or ASIC, or maybe GPU. For those who are not in this area, I think it means graphic processing units. Now the idea is, of course, typically a control loop will map into one of these devices. And of course, typically a control loop consists of the sensory functions, the computation of control laws, and then some actuation functions. Now, of course, within such a systems, we have many control loops. We can have a control loops which map into two microprocessors in this case, or many of them at the same time, and of course, they can share some of the functionalities. And we can have a controller which also share between hardware and software, meaning that some of the functionality is implemented in hardware, the others are implemented as software procedures running on this microprocessor. Now, with respect to this, my research is mainly focused on system level design, and by that it means modeling of functionality, design of the hardware platforms, and mapping of functionality, schedule of tasks and messages. On top of that, we have problems like hardware software co-design of control and embedded systems together, verification and testing. Today, in this talk, I am going to focus very much on this issue, mapping of functionality and scheduling of tasks and messages. With respect to that, we know that it is a very complex task because we have many constraints. For example, we have issues related to the very complex control functionality. We have heterogeneous architectures. I mentioned GPUs, for example. We might have different ASIC design, cache organizations, and then we have a lot of different communication infrastructures, such as CAN, TCP, and so on. And we have reliability issue, which we have to take care of. And now I'm going to focus on the temperature issue. Now, of course, by temperature, I'm not talking about the temperature in in outside room temperature. I'm talking about the temperature in the silicon, in the chips. We know that, of course, sorry, I'm going too fast now. With the technology scaling, we have very high power density, and this leads to high temperature of the chip, which will increase device failures. It will also generate a lot of other problems, in particular with the FinFET technology and 3D technology nowadays. On top of that, we have process variations which make the problem even more difficult. And of course, we have also very large ambient temperature, which means the temperature. For example, a car is operating. For example, I'm coming from Sweden, a vehicle, a car, should be operated in the situation now in the northern part of Sweden, minus maybe 30 degrees, or in the summer, plus 30 degrees. So there is a very large range. Unfortunately, high temperature has a negative impact on reliability, performance, power efficiency, and other issues. In particular, for example, the thermal impact on reliability is illustrated by this picture. In general, device lifetime will increase exponentially with increased juncture temperature. So, for example, here actually I have a slice in respect to a device which is from NXP semiconductor. If you have the device running at 105 degrees, then they have a lifetime of 13 years, which is relatively okay for mobile devices, the mobile phone. If the temperature goes up to 120 degrees, which is only 30 degrees higher, then the device lifetime will reduce to 5 years. It will become a problem. For example, in a car, in an electronic device in a car, you want it to run much longer than 5 years. With respect to that, we have to take care of this problem. On top of that, if you look closely at the typical temperature map inside a chip, here is the typical chip, you see that the temperature are high in some area and low in some other area. And the maximum temperature might also exceed the upper limit, which means that if you do not take care of the temperature issue, when the chip is operating, you might burn the chip. Of course, that is no good. Now, on top of that, we have large temperature gradients in this small area. For example, the temperature can come between 110 degrees in the clock generator versus 40 degrees, which is, of course, at the memory places. So we have 70-degree differences in 6 millimeters of gap. Now, with respect to that, we also notice that temperature changes also over time for a particular controller. For example, here is the actual temperature evolution. And if you look closely, we see that temperature cycling has also a large impact. In particular, in this context, we should not only consider the average temperature or the maximum temperature, we should consider how the temperature has changed. In respect to this, in CPS design, cytophysical system design, we can take care of this cycling aspects in the design process. In particular, if you look closely at this particular temperature behavior, it corresponding to a situation where we have a cytophysical applications where we have many tasks, as shown in this picture, which needed to be executed. And if these tasks are mapped on top of 2 processors, 2 microchips, which are executing the task, which are implementing in software, you will end up with such a scenario which indicating that the temperature, for example, can going up and going down. Here, each block demonstrate or illustrate the power consumption and the time. And you can see clearly that in this situation, if we do this particular mapping, we are going to see this temperature behavior. And if you just focus on the blue curves, we have 3 cycles. We can do an alternative design. For example, in this example, simply moving T5, so that we map into the processor PE1 instead of PE0. In this case, we generate now only 2 cycles. And we can even look into now the lifetime of these devices. And we see that, for example, this device will have a lifetime of X. Then this one will have a lifetime of plus 45%. This means that we can improve the, of course, the lifetime by doing these different designs. And this is the basic idea of our work. And now I see that my time is already running out. I will jump over a few slides and going to talk about, sorry, maybe then it's jumping too much. Talk about the algorithm. So our idea is to formulate this problem as an optimization problem, how to decide a design with respect to the mapping and scheduling so that the lifetime will be longer. And we are using a genetic algorithm, and I do not have the time to go into detail. You can read the paper to understand that, and we can talk about the implication or the experimental result of this approach. You can see that now with this optimization algorithm, we improve the lifetime by, for example, 39 times. These are not percentage, up to the maximum is 39 times, and the smaller one is 30 times. And the energy consumption here remain almost the same. And on top of that, we have also applied our technique to a concrete industry design. And we get, in this case, 23.6 times improvement with respect to this industry product, which is part2 video decoder with 34 tasks, which are deployed on a U4 platform. Now, usually, when we propose such an optimization algorithm, people are always wondering about the scalability of the algorithm, meaning how much time does the algorithm take to finish the task. And you can see here that when the number of tasks is small, for it, we take very little time. For example, in this case, I think the execution time is in seconds. So it's 7 seconds, and then it goes, of course. And this is due to that we are using a very fast method to do dynamic steady-state temperature optimization. On top of that, I'd like to mention that actually the execution time in our case is not so important because they are design time optimization, meaning that they are performing within the design time. And usually we have quite a lot of these design time to do a nice design in order to get a better, of course, solution. With this, I'm done, and I would like to quickly conclude what I have been talking about today. I have been talking about cyber-physical system design, and of course we know that it's quite complicated because we have stringent requirements on reliability, I was talking about, also performance, which I didn't have time, but power efficiency is also an important issue. These techniques are all impacted by the temperature of the chips, and this is what my focus on of the talk today. Therefore, we need to take temperature into account in both the design and operation processes. In particular, the interplay of these different issues in the system level design phase should be considered. And we need to develop, therefore, efficient design and optimization algorithm to take all of these issues into account, including temperature. And with that, I thank you very much for your attention, and I hope there's some questions.
Time for questions.
I have a quick one. So on that plot where you show the temperature over the chip, how do you measure the temperature at each point in the chip at such a small, at micrometer level?
Okay, very good question. In case you have not heard, he was referring to the temperature map I showed, right? Different temperatures. Now, okay, first of all, there are many approaches to do that. At the moment, we can use thermal simulation to actually get the accurate position of the temperature. Actually, that particular temperature map is taken by actually an infrared camera, which can get the information. On top of that, related to your question, is that nowadays, most of the silicon chips have temperature sensors, which are built in, but of course, not in such a density. So, for example, a chip might have maybe 10, 20 temperature sensors, which are distributed in a different area. And this temperature sensory information are used to help during the operation time. For example, if the chip has 20 core, meaning 20 computers or 20 microprocessors, and and each of them is equipped with a sensor. Then in one of the sensor indicating that the temperature of that particular core is very high, then you should stop mapping or executing tasks on that particular microprocessor, rather moving that functionality to other microprocessors. And in this way, you avoid burning that particular core. And this technique is, of course, in a lot of cases also standard. Mostly, if you have a laptop nowadays, it's also equipped with actually a temperature sensor. And they will slow down, by the way, in order to reduce the temperature. Of course, first of all, you can stop it and move the task to some others. Alternatively, you can reduce the frequency. For example, if you reduce the clock frequency, of course, the temperature will be reduced. And that is the technique which is mostly used nowadays. Thank you for the question. Any other questions? No? Okay. Yeah. We can switch another way of introduce. Now in this way, since the section chair is also the speaker for the second paper, so I would like to introduce him so that he can, yeah. So it's TOEFL ICECET2023 and he's from this company called, or organization called XCOM. He also mentioned that he's also doing lecturing from time to time in the Cape Town University of Technology. Okay, so TOEFL, go ahead.
Welcome, everyone. As the introduction, my name is Epos. I'm from Gascon. So today we'll be looking at the application of structuration theory in software testing within the organization. My comments, I'll just introduce my style, and then look at the literature review, then go to research methodology, data analysis findings, conclusions, and acknowledgement and references. As you know, all organizations, they depend on information systems for their businesses. So, for software testing to occur, software needs to be developed. So usually the team, the development team, or the entire team will decide on which methodology to adopt, which can be either traditional methodologies. So people normally, if something goes wrong, they put the blame on a framework or methodology, which I think is inappropriate, because the methodology is there just to guide you on how to do things. The most important thing is how you manage activities within software development and sector. So, testing is a process whereby a system is validated against user requirements in order to make sure that there is a relationship between the system that has been developed and the user requirements specification. Any mismatch will be required SE defect, and then it will have to be fixed, and then retesting has to take place. As I mentioned earlier, that for software to be tested, it needs to be developed, and then software testing will take place. So, software testing is a process of testing software to ensure that it functions as expected without any problems. Because should you implement any software that is not functional, then it will interrupt your business, and you can also take your reputation as an organization. So once the software is being tested thoroughly, then it needs to be implemented. Then business can continue as usual. And then earlier I mentioned that I adopted structuration theory. Lately, there's become a norm in information system field to borrow these theories, they are sociology theories, into information systems. So we also use them as frameworks for us to be able to analyze our data. So for this paper, I adopted structuration. Structuration was created by Giddens. This is how structuration looks like, but we'll have to explain some few things about the structuration, because before you can adopt this, you need to understand how these standards are being used for data analysis. So structuration is about the social system that is created by both agents and structure through duality of structure. So duality, it means the two opposites. It means the two opposites which do not relate, meaning that for structure and interaction to communicate, they are joined by the modality. So basically, the structure and the interaction, they are far apart from each other. But for them to communicate, you need the modality. So the social system is an environment whereby time is spent to learn how people interact, which enables the social system to grow. And the structure, it means a set of rules and resources that are used within the social system. And then we've got agents. Agents have the power to make a difference. For example, it helps us in reproducing structural resources. And agents make use of agency as a goal to achieve what they want to achieve. And then what we did, we adopted quantitative method in conjunction with the case study. The reason being these two are always meshed for you to be able to get in-depth understanding of how a phenomenon is being investigated. So for this purpose, it was around software testing. To collect data, we adopted semi-structured interviews. The reason being with semi-structured interview, you are able to probe if you don't understand something. And then it helps you to gather more data. Actually, it helps you to gather rich data because you get that from participants verifying whatever answers they give. And I used one of the government departments, so I named them as some technologies. So here our agents and structures were from the IT department. Agents were both technical and non-technical, and the structure consisted of rules and resources that could be utilized in the software system. So these are our findings after analyzing the data. We realized that there is poor management whereby timelines are enforced on people, and policies and standards were not followed during the testing. And then there was also a level of compliance. As you know that if you don't comply to the processes and standards, it means you are setting yourself up for failure. And then your failure will be producing poor quality software, which I think the organization would like. So these are some of the factors that we were able to pick up. Unrealistic timelines were given. Timelines were imposed on software developers as well as testers. And sometimes testing will take place in production, which is totally unacceptable because it disrupts business. And also we realized that there was a correlation between software developers and software testers, because most of the time, software developers, they think that when you log a defect, it's like you are saying they didn't do a good job. Instead, testers are assisting them to find defects and give them a solution on how to solve those defects. So as a result, the two needs to work very closely to each other for them to achieve a quality software. And we also realize that this lack of testing knowledge, some people within the organization, they only knew that testing, software testing existed, but they never had the enough knowledge of software testing, meaning they didn't know what software testers are doing. And we also found out that there was a disconnect between project stakeholders, whereby software developers would normally fight with testers thinking that they are not supporting them by making defects. Timelines were also imposed on software testers, which compromise the quality of the system. In conclusion, if you don't follow your policies and standards, you are setting yourself up for failure. And imposing timelines on the staff, it also sets you up for failure. And also, it is important for people within the organization to be well informed and comply to the processes relating to software testing and implementation. So here, I would like to thank the organization for supporting me, because they paid for everything for this conference. Here is my references. And thank you.
Any questions? I have one here. So you are talking about software testing, and then usually people are curious about some more quantitative data to support, for example, a particular software testing method, for example, the one you propose. So I'm a little bit curious because, of course, I'm not working in the software testing area, but I'm working in hardware testing area. There we have, for example, we have fault coverage. For example, we can say, okay, if we're doing in the low hardware level, we have the gate level fault coverage, we define 100 fault, and then you have a method to say, if I use my method, I can cover 98% of the faults. Then it leads to a matrix of quantification, say you have 98% fault coverage. And then you can compare different approach to say, for example, if you achieve 99%, then yours is better. Okay. So my question is, in the software testing community, in your case, what is the metrics you are using to quantify or to answer this question, how good is the test methodology?
Remember, here I was just explaining the functional part of it. We also have tools that enable us to measure how robust the system is. Usually, we've got performance testing tools where we are able to measure the load on the network testing. So, with those tools, we are able to pick up when the system is performing better, and when you put more load on it, then it will start misbehaving in a way. So, software developers will be responsible for enabling the software to be able to respond to any type of load and perform. Because previously in Johannesburg, we had a registration system which was tested perfectly and it was working functionally well. But they forgot to do the performance testing. So when the system was released, parents had to log throughout content, and then the system crashed because performance testing was not done.
Okay.
So they had to stop there and go into performance testing. And then thereafter, many people were able to log onto the system. Okay. So when measuring quantitative methods, we are able to use the software that will enable you to do measures.
Perfect.
Yes.
Thank you. Any other questions? If it's not the case, then I can also, on behalf of the organization, to deliver this to Tefro for this nice one. Okay.
Our next speaker is Philippe Maravani, and the title of his paper is Factors Affecting Software Quality Improvements in South Africa. So software development in the software development environment.
Good afternoon, colleagues. As the chair has introduced me, I'm Sidek Marwan. I work for Swami University of Technology and in the Mpumalanga province of the country. My study is looking at the factors that are affecting software quality improvements in South African software development environments. I'm just following on what the previous speaker has touched on in terms of breaking the monotony, because since morning we have been listening to a lot of papers that focus on the technical side of things, not on the human side of things. My presentation will be unfolding as follows. I'll start with the introduction, go through the study problem, the green method, results, and finish the presentation with conclusions of the study, recommendations, and future works. Okay. In terms of the introduction, I'm sure we are aware that because of digital transformation and other initiatives in organizations, there's an appetite from organizations to move to digital platforms, including those that are software driven. Organizations are automating their processes by including functionalities that are rendered from software. However, we realize when we look into the software development area, we realize that the issue of quality keeps on recurring as a challenge in software development. For example, if you look at different reports and literature that is written on software quality, you realize that the total cost of poor quality in organization has a serious impact on organizational processes and on economies. For example, if you look at one of the reports that was released by the CPSQ, it shows that in 2020 and 2022, alone only in US, the amount of money that organizations suffer because of poor quality software is 2.08 trillion and 2.41 trillion. So you can see there's an upward trend. But despite all these challenges of quality, the demand of software keeps on increasing. For example, if you look at one of the reports, the 2023 Global Software Value Trends report, it shows that businesses have increased 70% on software spending. And most of this happened during the COVID period and after, which is equivalent to 11% of market growth, and the dollar value is 880,000. So, if organizations are continuing like this and an upward trend in terms of adopting software technologies, while software is continuing to be a problem because of its quality, then we need to find ways of making sure that businesses get value for the money that they spend on software. And one of the things that needs to be done is to make sure that attention to quality is in the forefront of all the plans in the business organizations. So therefore, software development environments should make sure that they have proper software quality assurance processes, standards, practices, and also structures that are geared towards supporting quality. All right. So one of the problems that is trying to solve, when we look at literature shows that measures of failed software projects, they fail because of quality. And one, it is because organizations, they have not made the issue of quality a primary concern in their strategic planning. As a result, they're just focusing on meeting the customer requirements in terms of delivering software. So that means organizations are not tuned to sufficiently support quality initiatives. If they do, the most focus is on the quality process, which is just testing, overlooking human capability and technology-related factors. And also when we look at literature, why we have to do this study, we realize literature also focuses more on quality practices. You know, what methods are they used, what tools are they used, and so forth and so forth. Overlooking, not giving sufficient attention to factors that relate to humans. So this paper is trying to exactly close that gap, to look into the South African software development environment, to check what factors, human capability-related factors, are considered important for improving software quality. So what we did, we ran an online survey as part of a bigger project. So this paper is started from a big project. The data was collected in the South African development environment. Unfortunately, we only ended up with only 103 responses, despite the fact that we ran the survey over a long period of time. Because this is just a conference paper, our analysis is also limited, so just look at the basics. And these are the demographics of our respondents of the study. As you can see, in terms of gender, majority of the respondents were male, and the female only constituted 11.65%, which maybe says something about the social environment in the country. And the age group shows that those that are in the ages of 30 to 39, they are the majority of the respondents, and more. In terms of qualifications, most of them had a diploma and above. And in terms of experience, the respondents, most of them, they have more than 10 years working experience. What do they say in terms of the factors that they consider being relevant or important to improving software quality? Number one is that the shortage of personnel, unrealistic timelines, lack of technical skills, changing requirements, technological problems, and reliance on technical resources. So, majority of them, if you look at the shortage of personnel, they agree in terms of unrealistic timelines, in comparison to the previous speaker, software developers and testers are always confronted with the issue of limited timelines, and that also makes them to not give sufficient attention to quality, despite the fact that they have skills, because here they indicate that they do have the skills, but the challenge is time. The other challenge that they have is they have raised is that the software requirements keep on evolving. I think that is the nature of most software projects, that clients want to change requirements because they want to keep up with technology and also changes in the needs of the business processes. All right. So, in conclusion, this study, following the previous studies, that indicated that they focus more on the technical aspects and overlooking the human capability-related factors. So this study shows that in terms of capacity, they do have capacity in terms of the number of staff, the skills and knowledge, and their ability to use technology to improve software quality. However, they are challenged by the evolving requirements and the limited time allocated to do proper testing. Right? And also, the issue that has also come up, if you look at the graph that I showed there, is that it looks like companies rely more on the internal resources and overlooking the other opportunities that are out there of sourcing out talent from the freelancers and people outside the organization that will look at this from a different view. And it also shows that it looks like this usage of external testers is not a common practice in the South African software development landscape. All right, so in terms of recommendations, yes, we recommend that the organization are encouraged to look at the factors and that promote quality improvements, make sure that they are measured, and those that are found lacking, they need to be addressed. And yeah, so we also recommend that they must start looking at the talent outside organizations to build up their capacity. And in terms of the way forward, we looked at the data, we realized the South African software development landscape is very big, it's a huge market, but we only managed to get 103 responses. So we find it difficult to really generalize and say this is the true feeling of what is happening. Therefore, we recommend that further studies be conducted that will take a leaf from this one in order to tell exactly what is happening in the software development environments by looking at the bigger population as compared to the sample that we've used in this study. And I thank you very much.
Are there any questions for our speaker?
It's not a question, it's just a comment. You know, there are so many researches that are made regarding development and the topic that has just touched on. But from experience and hearing what is happening in companies, there's a lot of sabotage. People do research, people give their inputs for systems to be up and running. But based on the greediness and whatever, this is the failure that is making all this hard work not to be implemented. It's just a comment.
Thank you so much for the comment. And just also about my presentation, I mentioned that there are processes, policies, and standards, and normally
Deviate.
no, not necessarily, but they are not followed. So if you don't follow those things that have been set up in the company, then you are setting yourself up for failure.
They don't care.
Any other question? Thank you so much. So, Mr. Marawan, is it for you? Yes. Thank you for listening. Yes, our next speaker is Stefan Rosé, and the title of his paper is Control Room, Monitor Software Engineering or Working, fully autonomously at high speed.
Thank you very much. Yes, let me start with the control room monitor software engineering robot working fully autonomously at high speed. The Ballstifter is Germany's largest pension group under public law. It operates the core applications Corona in the production room and uses it to process sensitive data from around 5 million people. More than 1,000 clerks continually exchange this data. The IT service provider Capgemini maintains the core application Futura. For the test, Capgemini developers need anonymized duplicates of the databases. Bayerische Versorgungskammer creates the anonymized duplicates for Capgemini using an anonymization tool. The author developed the new software engineering robot Nora maintains the anonymization tool fully autonomously. Nora looks for gaps and closes them by anonymizing. Nora uses an expert system to complete this task. In the way, Nora can continuously modify the changes of class because these changes can cause gaps in anonymization. Okay, go to the customer request. The customer wants that an anonymization tool should anonymize new attributes. The customer therefore enters these attributes into a specialist concept. Nora reads the change request and identifies the necessary adaptations. Nora then creates the anonymization specification and enters the new attributes into it. The customer reviews the anonymization specification and compares it with his change request. Nora adds the new attributes to an XML anonymization configuration that is stored in a database table. You see that? The database table is there shown. Nora then spools the changed contents of the database table into an XML file. Then we go to the next slide, and there we see the using of the anonymization tool of the spool file. And the processing of the spool file should now start. The anonymization tool reads the spool file. The timed cron job starts an RNA duplicate. The RNA duplicate copies the production databases into the developing room. Nora adjusts the configuration of the anonymization tool and starts then the anonymization tool. The anonymization tool reads the configuration and the copied data and anonymizes it. Nora looks for gaps in anonymization. And the processing of the gaps by Nora should now be shown on the next slide. There we can see how Nora works. Nora writes a programming command to close the gap. Nora inserts the change request and the programming command into a communications database in the developing room. And the chief programmer reviews the change request. And Nora copies the successfully reviewed change request into the production communications database, thereby closing the gap in anonymization. And then see how Nora developer changed the verified flag in the change request from no to yes, you see there. NORA registers the successful review of the change request and creates a specification for the change request, which the customer then examines. Finally, NORA adds the recognized attribute to the XML anonymization configuration, closing the anonymization gap. The operator starts the arming duplicate. The arming duplicate reads the Futura application data from the production room and copies the database into the test room. You see there, the copy process. The operator starts the anonymization tool. The anonymization tool reads the XML anonymization configuration on the left side and the copy data from the test room. The anonymization tool reads NORA's generated update commands from the production room's communications database and executes these commands. Then the anonymization tool creates an anonymized database in the test room. Now we see NORA components. NORA uses a virtual sensor to look for gaps in the anonymized data in the test room. NORA sends the anonymized data to an expert system for review. The expert system's inference engine uses a knowledge base to decide whether a gap in anonymization exists. If the expert system finds a gap, NORA starts the code generator. The generator generates an update command for the heap which closes the gap. NORA then writes a generated command into the test room's communications database. NORA can process customer change requests fully autonomously. NORA completes this task with the help of an expert system. With this expertise, NORA works as a fully autonomous software engineer. Coding and specification modules make it possible to execute a complete software engineering workflow. After a successful review, the application gets NORA's changes. Current state-of-the-art robots in software engineering can only support the developer because they do not have access to an expert system. Therefore, the developer must complete the change request. The robot only relieves the developer by executing routine technical work. Only the developer has the expertise to maintain the application. Now we are at the end of the presentation. Thank you for your attention.
Thank you so much. Are there any questions for him? Any questions? Our next presenter is Nazir Joseph. Is Nazir around? Okay, speaking. And then we move to Alesso.
Yeah.
Bushaini.
Bukayo.
Right. Thank you so much for the introduction and welcome everybody. I am Alessio Bugaglioni and I am an associate professor in computer science at Maranello University, Sweden. And today I will present this work which I am doing in collaboration with my two co-authors, Marcus and Federico. But also this work has been done in the context of a collaborative research project which involved Volvo, which I guess you know, and then after the system is suspended a Swedish software company, and Artem, which is a American French consulting company. So before to go into the details of the work, I just want to give a little bit of background, right? So where we started with our project. Basically, I guess you all experienced the fact that vehicles in the last decades basically shifted from being mechanical intensive system to software intensive systems, right? And then the complexity of the automotive software system has been constantly growing in the last decades to a point that, let's say, we have now cars that are shipped with 100 million lines of code. Of course, the let's say functional complexity of this system is not the only, let's say, point of complexity. This system have other concerns which make their development, let's say, intricate. Some of these, for instance, are the fact that automotive software systems are, of course, hardware-time system, meaning that in case the software fails in delivering the functionality within a given deadline, then we may have serious consequences to the people, right? And of course, because of this, we also have a lot of safety regulation and requirements that we need to take into account when we develop these software systems, such as the regulation that are stated by the ISO 26262 standard. Because of this increasing complexity, researchers and practitioners like us in the last decades started to investigate the use of new techniques, software engineering techniques, in order to basically tackle this the complexity related to the software system and the development. And among several techniques, all of those techniques that are available, I just wanted to mention two that I've been working with. And one is, let's say, multi-parallel modeling in general, or more broadly, I would say, model-based software engineering or model-driven engineering, whatever term you may be familiar with. So in general, the idea that you have instead of coding directly, you use models and then you manipulate these models automatically, so that you transform them from like more abstract to more concrete, or you may even generate directly code. And then of course you have like on the other end, you have the principle of agility. So we start to change the development processes to be always more and more agile, though of course in this critical domain we still need to be compliant to the safety safety certification and their certification. Anyhow, as I said, I've been personally working with this, and some years ago, when I during my last year of PhD, I together, of course, with other colleagues, we defined and implemented a development methodology that we call MOOS. That simply is a model-based development methodology that aims at using the models and model transformation for providing early feedback with respect to non-functional requirements of this software system, such as time. So here, very briefly or very fast, I just wanted to basically tell you how it works. So if you think that, if you think about the development process going from the requirements to the code, so from very abstract specification to very concrete ones, then at one point you may want to use models, as I said already, and then in our methodology we advise, or we actually do use these models, but what we do is that we do not use them only for representing things, but we formalize most of the aspects of these software systems, and then we automatically, as I said, manipulate these models. So basically we generate other models automatically using the so-called model transformation that are simply computer programs, and by leveraging or capitalizing on this automation, we are able to provide early feedback on, let's say, as I said, non-functional requirements such as timing at early stages of the development process. So we don't need to wait, let's say, that we have a prototype or a code or the code of our system in order to, for instance, say whether or not a function can meet the timing requirements that are specified. Most importantly, what we do is not only provide these, let's say, evidences, but we also store the results of this evidence on the starting model. So to support, as I said in the previous slide, also a more agile and continuous, let's say, everything approach. So this is the general, of course, application. But then by doing these years, I had the chance of applying different contents in different research projects, and these are just, let's say, these two are just like a couple of examples of how we actually use or instantiate this methodology. So on the most left side, you can see that we, for instance, instantiated with some technologies such as STPM, the robust component model, and we perform analytical timing analysis as well as the analysis of tracing, basically the simulation traces. On the other side, instead, you can see that, for instance, we use other technologies. In this case, we use Amartia, which is another modeling language, always for the taught or developed for the automotive domain. Now, what is the problem? The problem is that if we go back in this very simplified schema, the problem is this is not really, let's say, continuous in the sense that for this to happen continuously, this cannot happen, let's say, this process cannot happen continuously because we manually need to, let's say, instantiate this process each time. Clearly, we have a new starting model, okay? So what we wanted to do in this, in this paper is to build a pipeline that could automate this process, okay? So this is more, we can say, is a more applied research work, even though in doing so we actually also realize a couple of things that are maybe of interest for others that are approaching this. So anyhow, the contribution of this paper that I'm presenting, as I said, is this pipeline that also you can see graphically represented by this figure. And in the next few slides, I would say some detail about at least the research process or the design of this pipeline. I will not enter into the details of implementation, which you can find in the paper. I think in the paper we also provide the link to the GitHub that is fully accessible if you want to try it out. And of course, if you have any more specific question related to the implementation, you can also always contact me or Marcus, the first author. Basically, as I said, I would like to talk about things that we thought they were, let's say, relevant and unique in a way while designing this pipeline, which I summarized in this slide. The first one is the way we actually handle in failure. So generally speaking, when you have like a pipeline, if you have a failure, you will want to basically stop the pipeline. However, in our methodology, even when the timing analysis over here will fail, we still want that result to be logged, because we want to know that the timing analysis was not, or the timing constraint was not met back then, and we want to log this information in the starting, as I said, in the starting model. The other thing is that the parallel execution of the different steps, because as you will see in this application, we basically may have different analysis processes that can go in parallel. So in this case, we have analytical timing analysis, let's say, and the analysis of the simulation trace. We also have to parallelize this pipeline, and because of this, we basically had to use different environments, different tools and machines. The problem here was that, for instance, different machine would require different, for instance, operating system environments and so on. So we had to distribute this pipeline in, as you can see here, which nodes. One that is like a Windows node, and the other is a Linux node. So here I also, again, graphically put the pipeline where I pointed out how, or where in the let's say, the pipeline you can see the characteristic that I just mentioned. So another part of the contribution of our paper is that we actually applied this, or let's say validated, even though it was a very small validation, the pipeline. So what we did is that we took a couple of use cases from our industrial partner, Volvo. The one above is the brake-by-wire functionality, is then the one below is the weather motor of vehicles, and we applied this basically the pipeline that we created for the NUS methodology in these use cases. And of course, as I said, I will skip all the boring details, but essentially what you can see here is that we were able to automate and achieve a full, let's say, continuous process, such that each time we were automatically modifying the starting model, all the chain was applied again, so the methodology will run automatically. Very shortly on what we learned, some things that you may want to take into account when developing such pipeline. There is not just automation that you need to provide, and then of course take into account all the specific aspects. For instance, in our case, the previous solution that we explored, like Jenkins, where it was not feasible because of the lack of interoperability. So we actually, let's say, developed this pipeline as a GitHub function. So thank you so much for the attention and questions. If you have, I will be happy to answer.
Any questions to the speaker? Next presenter is Mary Ruler.
Hello, I am Schneider. I work for a Turkish aerospace company from Turkey. Our first author, Melihwan, is not here because of the company issues. I will present the presentation for everybody here. My company develops helicopters and some avionic projects for the Turkish government. And I work for helicopter systems for Turkish aerospace. Basically, I work for Gökbey and attack project for it. It includes automatic flight control system and related subsystems. In this view, it includes Gökbey project details. It's like a 2-engine helicopter. It includes 12-person cabin, and it will be used both civil and military configurations. And this part of the Gökbey, we use automatic flight computer system. In this system, it includes 2 FCC. It's called flight control computer. This software is developed in accordance with the DO 178C, and it has the level A. And for software programming, it includes software, driver lists, and real-time operating systems in the hardware domain. It includes FPGA and etc. In this software, ICECET certification runs on 2 different real-time operating systems, which is like we use VX cores and integrity for these processes. Then it's the flight control system with FCC interface with the pilots, with pilot interfaces. And we use sensors for the inputs to FCC. Then we use these inputs for the automatic flight control system to have the actuators providing the autopilot system. And this presentation, we use phase for the software architecture, and it's a good code in there. Actually, phase is a future airborne computer environment, which is a guideline to enforce operating system and hardware independence, as well as software components usability and portability. It means that our system software is composed of segments that use each other's service, and it should be communicated with them with these segments. And they have like these kind of mechanism. It includes portable component system, transport service system, and the platform specific services segment and the IO service segment. These are the details for our system. We use IO system like configuration and device managers. Then we skip the PSS part, and it's like a layer system for our software. TSS is like a communication protocol between the last pilot interface and ISS and PSS. Idea behind the face configuration is it a good functionality is there, and it used for connect components with layers structure. And basically iOS configuration includes iOS channels and device names, PDS configuration uses libraries names and LRU components. And TSS is a communication system for between these layers, and the Fox components is the uses all iOS channels for the last interface. These are our application down below. It is an example for our LRU. It's called rather multiple system, and it used these. It used these, and these are data types, and it's used source of destination types, and these are the layer infos, and we use these configurations with the CSV files before this configurator tool. We developed this base configurator tool for develop our software more like a modular architecture. It enhanced the usability of the infrastructure underlying the face architecture. It's a good usability for the newcomers, and it reduces the number of operation steps. We have like a CSV upload implementations, and we use doors for the requirements. And after that, we made the changes in the CSV files and in the doors files. Then we basically generate, read and modify to these components, and we create the source and header files after that. Basically, this is the doors simulation. It's like a between client and server, and we use the doors for our requirements. After that, we generate the source files after the face configurator. It basically it is a PSS component. It's like a HRS, it's like a sensor system. It is the sensor system component channel. That is their detailed variables, and we basically generate with this system, and it tool goes to doors to synchronize these items. And maybe you don't need doors, then you read the CSV files for your local. Then it's variable inputs, and it's generating in these tools, then output is our source and header files. after this tool, the errors are reduced by automatical generation. Because of that, we designed this tool. And for the results, this is our results for all of the generated files. It is repeating like 1,000 times, but we don't write all of these like this. This is the generated file. And this file can be arranged with the tool interface, and this is the very good usage for new software engineers. It's like it is developed by unique configurations, and this is our results. We have 42 box models, which is our last interface, as I said, is the last segment of face configuration. And these are hard to write all of the codes. It's like a project, all of this, and it is all generated by this tool, face configurator tool, and it's like a it's like a line of code is right there, and it generates like this of all of the project. And the result of that, we compromise the reliance on data accessibility, and the simultaneous operation, the data config is compromised, and the use of all segments as a whole has been facilitated. After that, memories are reduced, automated processes are developed, and these are the other advantages. Maybe in the future we use relational database for this tool, because now it's only used to store some CSV files. Maybe in the future we use a database for each person and the main database for all of the operation. Yeah, these are our project future use. We have phase 2 and upper flight modes. Thanks so much.
Any questions for our speaker?
Thank you so much for being part of this session. We'll come to the end of our presentations. So thank you so much for being part of us. We have come to the end, so I enjoyed this session. Thank you. Thank you. Thank you so much. No, I don't. No, yes, I don't. Just move on. I go by. Sure. No, this is
the temperature is mostly normal, but it's becoming bigger and bigger problem.
Yes.
If you are working in this area, I'm sure that this will be some of the future problems, because you see transistors are becoming smaller and smaller. So everything's coming closer, and actually the temperature is becoming now the main limiting factors, which limited the further improvement of performance. So there will be a lot of interesting things.
For my application, you know, with radar we measure sub-millimeter, and that drifts with temperature. So now the receiver and the transmitter operates at different temperature. Your accuracy is kind of deviating. So we can control that. You can eliminate these other factors. Get the accuracy.
Exactly.
It's interesting. I'll definitely look up.
Okay. Very good.
Thank you.
Okay.
Are you present?
Yes.
Yes, sir.
Registration is on there.
All right. It's the wrong.
Thank you. Yeah, on the second one.
Okay. So, we'd like to start this session.
Yeah.
I'll take the session chair, and each presenter has 15 minutes, usually 12 minutes for presentation, and after that, question. And I hope you will keep the time schedule because we have 2 additional presentations here. Okay. Anyway, let's start the first presentation. Please start.
Right. Good day, everybody. My name is Alfred Barnard. I'm from the Institute for Automation and Communication in Magdeburg, in Germany, and we're going to be talking a little about digital twins, the asset administration shell, and some communication protocols that support all of this. So these are the topics that we're going to work at or look at. We're going to touch on any of these, all of these, so we don't worry too much about it. So let's start with the introduction. So we'll start with, from the outside moving in. So what are digital twins? Well, as you've all probably heard today, they are physical, well, they are virtual representation of physical assets. In terms of asset administration, when I talk about assets, it is anything that you can connect to your Internet of Things network. I will call that an asset. So this goes about how do we manage all of those assets. Role of digital twins, well, it has been discussed quite exhaustively today. If you've been listening to the talks, in terms of asset administration, they just help us in terms of decision making. So they create data, we use that data to inform our decision making in terms of our assets. And then this comes down to the asset administration shell. It is a technology independent framework that we can use to create digital twins. And we'll talk a little bit about why that is important. And then the significance of data communication or datagram communication protocols, and why I like to use datagram communications in AAs and digital twins. So as you spoke about what a digital twin is, in terms of asset management, I'll speak about probably 3 types: product, process, and system. So a product digital twin is a very detailed informational model of that asset. A process digital twin is a detailed model of the process of manufacturing an asset, and then the system twin can be something as large as a whole manufacturing plant that manufactures other assets, for instance. And digital twin applications, we can apply it to almost anything. It's a little bit of a hobby of mine to try and find things that I can create digital twins and use it in day-to-day life. But a good example is the Uber app. So if you use Uber, it's basically virtual representation where you have a service provider and a client. You both have sensors, GPS, you both communicate with each other, and you can see a virtual representation where your Uber driver is at and where you are relevant to his position. Now we're moving into the asset administration shell. It is a standardized framework to create digital twins, and standardized is a very important element now. So if you have a digital asset, that digital asset might be made up of other digital assets. So how do you integrate all these digital assets? Well, you use the AAS. And once again, all this boils down to enhance decision support. So with the AAS, you have a framework, a shell, and you insert all the information you have about that asset. All the data sheets, part numbers, components, everything about that specific asset you fill into the framework, and that also includes all sensor readings that that specific asset might have. So AAS, as I spoke about earlier, it's supposed to be a technology-independent framework so that it can interact with other frameworks, other asset administration frameworks. And it helps with the integration of heterogeneous systems. Now, all of this is an aid of the Internet of Things. Very important in the Internet of Things, we have communication, because all these systems communicate. And popular protocols in QTT, obviously UA. Now, I was going to speak about some considerations you have to think about when choosing these protocols. But a lot of the times, you are very limited in the choice of protocols. A lot of manufacturers like to stick with their own protocols, and you are like tied to use the protocol they have used. But for considerations, low latency, relatively low overhead, reliability, and then cost. And also within the AAS, we can have hybrid approaches, meaning that you can use different communication protocols, and they can all communicate within the asset administration shell. Now, I like to use datagram communication. So datagram communication, all the information is sent with separate individual messages, heading, message content, and that is sent independently if there is a constant connection or not. The message is just sent and hopefully received. But usually if we're dealing with AAS, we would have some sort of server that would would collect these messages. And datagram protocols, they're great, relatively low overhead, relatively efficient, lightweight and scalable, and you can broadcast your message to several different assets at the same time. And also relatively fault tolerant and resilient method of communication. Now there are quite a number of case studies and applications using digital twins and AAS. I'm sure you've heard of a couple. But in the manufacturing industry, my organization, IFAB, we are helping with a project called Twin Map, where you create a system twin of your manufacturing industry. And when you want to create or produce a new tool or a new asset, the digital twin will tell you the most optimal machines that you can use to create your product you want to create. So you provide it with the details of the tool or whatever you want to create, and then it will tell you which path it needs to follow to be completed most efficiently, most cost effectively, and so on and so forth. So if you have a factory with 5 or 6 different 3D printers or tooling machines, it will select the machine that is most suited to the production of your specific tool. Energy management. Now, energy management and smart cities cannot go hand in hand. I just took through the presentation from colleagues in Greece, where they created a digital twin of a small Greek island, and all of the energy produced from the island, they have created a digital twin for that, and that helps them in their decision making in terms of their smart grid applications. Healthcare and medical applications, so we spoke about in the keynote this morning, a lot about the digital health of Africa, and digital twins can help alleviate that. So you create a digital twin or a digital representation of a patient, and that patient information then travels with the patient with all of the medical history, current medical readings. If that person is in the hospital, you can have all of those sensor readings taken for his heart, blood pressure, and so on, being drawn into a digital twin and then readily available to whoever has access to a digital twin. Transportation and logistics. The Uber app, very good representation of a digital twin. And also in Germany, we have the Deutsche Bahn app for trains. We can basically see all the trains running throughout the country. Granted, they are almost always late, but you can still see that they are late by a couple of hours. And then lastly, we have a project called Resistant, where we create a digital twin of an aeroplane, and we use that digital twin to try and detect any cyber attacks or any compromised elements of that specific system. So limitations, as with everything engineering-wise, there are limitations. So interoperability, I speak a lot about AAs being standardized, but there are still a lot of resistance against using all standardized, all using the same protocols. Some manufacturers like the protocols they are using and are some a little bit resistant to protocols that are all standardized. And also infrastructure. If you do not have access to the internet, a digital twin is a very hard thing to maintain. And then ethical and social implications. If you have all this data, especially sensitive data about patients, you will have to guard that data quite rigorously, and what you do with that data, especially anything related to patient health, might have very serious ethical implications. Future directions, as with everything almost nowadays, is based on AI. We have lots of data, so we need some way to analyze and use that data. So AI is great for that. Also, integration of edge and cloud technology. So you want to have more computation done closer to where the sensing is being done, or you want to send everything up to the cloud to be computed on in a server somewhere else. And as you spoke about data privacy, security, and the ethical social implications. And also the integration of physical and virtual worlds. So how does virtual reality and augmented reality all fit into digital twins and our use of them? Also, how scalable are digital twins? And also, how complex can we make them? Or how complex is it useful to make them until they become too hard to maintain? In conclusion, I'm right on 12 minutes right now. As we all know, digital twins are incredibly useful and revolutionizing our digital world. And it's not just Industry 4.0, it is almost everything that we are dealing with now is somehow connected and somehow out of context for us to use. We have to have some framework, some standardized framework, like AAs, to help us deal with this. A little bit rushed, but that is my presentation. Any questions?
Thank you, sir, for your presentation. I heard you saying that you send your data using a datagram protocol. Yes. I'm just interested in knowing whether you were not concerned about the integrity of data, or maybe loss of some data in the packet.
Yes, you're right. As in everything we do, there are trade-offs. So, what's more important, low latency or data integrity? You have to decide for your own application what is more important. If it is something real-time, life-threatening, then yes, something that is low latency but also very high data integrity is very important. Then something like datagram might not be that applicable. But if I'm talking about the life cycle of a asset in a manufacturing plant, data loss or packet loss might not be the most important thing.
We can accept another brief question. Okay, thanks so much.
Okay. Thank you very much.
later. For presentation, you have a survey, and after that, question.
Thank you, Chair. My apologies for coming late. I was trying to get my student to come present so it was better than I do. But if there's questions, please let's send those questions to me. I would like to talk about design of an IoT-based energy monitoring node. This will be my agenda. We get the initial aims, activities, methodology, designs, results, experiment analysis, and then summarize. The management of energy is important, as we know, that there is a shortage of electricity in many areas across the world, especially in commercial and residential areas. But the problem we have is the drastic nature of the system, such as occupancy and other activities in a building. So we are not able to actually predict accurately what's going to be the next device platform. So we need to be able to provide the detailed information about the appliances used and produce an accurate or adequate data set used for effective node disaggregation with unintrusive systems. We've looked at what has been done and found out that in terms of cost, nothing is reported. In terms of communication range, it hasn't been considered. Something has been done in terms of monitoring and controlling appliances, and some error calculation needed about 0.6% voltage current monitoring. We've seen some 2% for current and some 4% deviations for voltage, and decreases of voltages are shown in the next line. The aim and objectives of this project is to design a low-cost IoT-based sensor node monitoring electrical power or electrical outlet. Some sub-objectives include, among others, the importance of providing alternative data storage methods, as well as transmission of data easily. Also, validation for multiple types of home appliances. Errors and potential noise assessment needs to be considered in improving our node. This is the methodology that we followed. We designed the hardware and implemented it. We did some tests using various appliances that can be found in a typical building, and we also evaluated the results and measured them against some known equipment, like a car meter or something like this. and then we assessed statistically some errors using some tricks of statistics. Here I show the design of the flow, how the system works. Every 200 milliseconds we sample current and voltage, and we take the treat value to the next stage. We take the current value via the U1 protocol through the Arduino to the ESP. The Arduino and the ESP are different in terms of their capabilities, so we're going for the Arduino and the ESP in our design. And some of the bulk data then is sent to the offline SD card, as well as to the server, server via the ESP32. Here is the picture schematic of the design. You take a typical appliance, you sample the voltage and current, and then you send it to the offline storage bank, as well as the server. On the right, we show the schematic of the same thing. Here is the experimental result, where we show the setup, and one of the few, in this case, three devices signatures are shown. The first one is the bar signature, the iron signature, and this is the microwave signature. One of the measurements are shown here, some of the measurements are shown here of the comparisons we're making between the system as well as traditional unit, and we've discovered the errors as shown here. I'm not going to talk much about that. And here we show the distribution of error, as well as some linear regression graph shown there for the different devices. And here I want to try and summarize to say that the design of a low-cost Internet of Things home monitoring node performance was evaluated using the linear regression distribution of measurement of errors, as well as by comparing the node measurements with the power meter unit. The outcome of the research is that we found good linearity in general, and we found that there's also good accuracy levels and precision levels. For the future, we think we can make some improvements. Well, in linearity for low power devices, we can improve on that, as well as the noise amplification for high power devices, like the microwave. The importance of the study is that it opens the door for future development of embedded architecture capable of effectively monitoring appliances, as well as performing load disaggregation at the same time. And so we think that some work can be done there. And yeah, that's it. Okay.
question. So you are developing a sensor node, and after sensing, how do you use the measure data? I mean, for what purpose the measure data are used?
Just repeat your accent is my problem.
Okay, so I thought your main target is one of the main targets is the home appliance.
Yes.
And so you measure the home appliance power consumption.
Yes.
And after that, what is the purpose? Automatic control or just
Basically, users of, how can I put it? Users are not aware of how their appliances are doing. And in general, you would like to find a way of automating this, bringing it together into one place. Let's say, for example, in the form of an app, a user can be able now to see what's going on in terms of how power is consumed in their building or in their home, and make decisions based on that. For example, you could come to a point where you actually are able to even predict, based on the current available kilowatt hours, how long still can you go? Can you go for 2 days more? Can you go for 3 weeks more? If you switch off one of the devices, if you were going for 3 days more, you're going for maybe 1.5 days more. So the end of this project basically is to automate the whole thing and give control to the user. Yeah. And people talk about it. People talk about it. It's not really,
visualization.
people talk about this and it's not really used.
Yeah.
The end, as I said, the end goal of this is to actually get users, it's Internet of Things, smart. Get users using their energy consumption smartly and making decisions, having control and making decisions as far as that's concerned.
Thank you very much. Yes. Okay. Any question? Okay. Thank you. Thank you. Let's move to the third presentation. And the third one. Okay. Are you ready? Is it ready?
Okay, so the introduction. In recent years, object detection has seen a rapid revolutionary change in the field of computer vision. It is a technique that combines object classification and object localization, which allows for the identification and location of objects, either images or real-time pre-saved videos. The process of detecting objects and assigning them to classes of interest has always been an interest in computer vision research, as a result of its usefulness in a variety of applications such as autonomous driving, artificial intelligence vision, and video surveillance. It is also classified as one of the fundamental issues regarding computer vision and image processing, since it builds on the foundation of other image processing tasks such as object tracking, image segmentation, as well as learning and indexing. The objective of this paper was basically to provide a comparative study on key CNN object detector algorithms based on a laptop scenario, so that's using a possible personal computer with limited graphical processing capability. The first detector that I chose was the FAST RCNN, and this was proposed shortly after FAST RCNN was introduced by Russia in 2015. FAST RCNN introduced the region of interest cooling layer, which allowed for feature extraction for all proposed regions at once. This cooling layer extracted fixed size feature maps from the CNN feature map, enabling efficient processing. FAST RCNN was the first end-to-end and the first near real-time detector that inputs images into a CNN which generates a feature map. The main difference between FAST RCNN and the previous FAST RCNN is the introduction of the region proposal network. This resulted in nearly cost-free region proposals for achieving higher encoders while maintaining computational efficiency. The use of RPNs for region proposal generation eliminated the need for separate region proposals, algorithms, and improved the end-to-end training by sliding a set of predefined anchor boxes over the feature map at different spatial positions. FAST RCNN also brought about a gradual integration of most individual blocks from an object detection network into a unified learning framework, facilitating a more efficient and streamlined approach to object detection. The next detector is the YOLO, and I chose YOLO V3, but to start off, YOLO was first introduced in 2015 by Redmond and others, and this was the first one-stage detector that was introduced in the deep learning era. The YOLO algorithm can detect objects in real time, and the algorithm only needs to run once for the entire image to be processed. Since it applies a single neural network to the entire image, it divides the image into regions and can detect various possibilities and bounding boxes simultaneously. YOLO uses a combination of residual blocks, bounding box regression, and intersection over union to produce the final detection results. Over the years, many authors have made numerous improvements over this. We're currently sitting on version 8, but for the scope of this paper, I stopped at version 3, which was introduced in 2018. But before we get to version 3, version 2 introduced the concept of anchor boxes and parser layers and multi-scale training. This approach improved the network's ability to generalize across different object sizes, leading to better performance on objects of varying scales. The key contribution of YOLO version 3 included an updated network architecture, the introduction of multi-scale detection, and improved training techniques. The last detector is the SSD. SSD was introduced in 2015, which was the second one-stage detector in the deep learning era. This addressed the need for accurate and efficient object detection algorithms that could perform real-time object detection in a single pass. It only needs to take a single shot to detect multiple objects within the image, as compared to region-based detectors that require 2 shots. This greatly improved the speed of detection when compared to region-based detectors. SSD also brought about the introduction of 2 new detection techniques, multi-reference and multi-resolution, which significantly improved the detection accuracy, especially for smaller objects. The key innovation of SSD lies in its ability to perform object detection on multiple feature maps at different resolutions. This approach enables SSD to handle objects at various scales and capture detailed spatial information by incorporating multiple convolutional layers of different sizes on top of the base convolutional network. Moving on to the dataset that was used for this paper, it was formulated from the Caltech class 1999 and 2001 dataset. The reason for this is previous papers all use different datasets. So in order to provide a comparative study, a single dataset needed to be used with images of the same size. This dataset had 295 images and was split into 177 images for training and 118 for testing. In order to reduce the computational cost on a laptop, in order to reduce the computational cost of training these object detectors on a laptop, the images were resized prior to processing. A dataset round trip consisting of labeled images and bounding boxes around the vehicles was also generated. To further improve the detector's accuracy, random images were transformed using data augmentation. This required the images to be horizontally flipped with its labels, scaling of the image and jittering the color so that it included the brightness, contrast, and saturation. This, however, was only performed on the training dataset and not the test dataset, as the test dataset needed to reflect true or raw data. Looking at the performance results, precision versus recall curves and mean average precision of models have been computed to compare the key detectors. The figure on the left demonstrates that precision is constantly high and achieves perfect precision and lower recall values of all key detectors, but tends to fluctuate as recall increases. This suggests that the algorithm detects more objects through training. There is a possibility of some false positive detections, leading to a lower precision rate. It's worth noting that all key detectors generally show a high precision throughout the recall range, and is supported by the mean average precision values plotted on the graph on the right. Mean average precision is a common evaluation metric used in object detection tasks, which combines precision and recall across various intersectional Boolean thresholds. The faster RCNN algorithm achieves a mean average precision of 0.76, the SSD of 0.92, and the Euro version 3 of 0.81. In addition to these two analyses, the average detection time and loss of the key detectors were also provided. The results are summarized in the table shown. The faster RCNN algorithm has the highest average detection time of 4.8 seconds. This indicates that it takes a relatively longer time to process each image for object detection. The Euro V3 algorithm has an average detection time of 1 second, which is faster than the faster RCNN but slower than SSD. The SSD algorithm demonstrates the fastest average detection time of 0.3 seconds. This suggests that it processes images more swiftly compared to the other models, making it highly suitable for real-time and near real-time applications. The loss metric is an indicator of how well the model is performing during training, with lower values indicating better model convergence and performance. The average loss of 0.4 for the faster RCNN is performing relatively well in terms of minimizing the discrepancy between predicted and ground-truth training boxes. The SSD algorithm has an average loss of 1.7. Comparatively, this indicates a higher loss than faster RCNN, suggesting room for improvement in terms of model convergence and minimizing the discrepancy between predicted and ground-truth grounding boxes. Euro V3 has the highest average loss among the three algorithms, with a value of 2.7. This indicates that the model might face challenges in accurately predicting bounding boxes during training. In conclusion, the analysis of the detected performance results show that the SSD algorithm stands out in terms of average detection time and achieving faster processing times. Although the faster RCNN had a decent mean average precision, it falls behind in terms of detection time and average loss. Euro V3 shows a reasonable balance. However, it falls behind SSD in terms of the mean average precision and average detection time. For this paper, a small dataset was useful. However, in the real world, you require a much larger dataset in order to fully train the detector. The choice of the most suitable object detection algorithm ultimately will depend on specific requirements and constraints of the application that you are developing, as well as the desired trade-off between speed, accuracy, and loss. Thank you. Any questions?
Okay, thanks so much. Do you have any questions? Please.
Is there any reason why you decide or you have chosen these three models for your comparison? Or?
Yes, the reason that I chose these three is because it's easily available as pre-trained model on MATLAB. So that was the simulation tool that was used. So in order to compare the models, first I had to use a model that actually had a pre-trained model. So the detectors had a pre-trained model. So these three were ready which assisted in terms of not finding a graphics process unit to get a baseline to compare it to.
And do you think how many impact you have as a data set, because you have only used one specific data set for performance evaluation?
Yes, so the reason why I use one data set is normally when people compare or analyze detector, like I know with YOLO is maybe use it for like carriage recognition, not for an actual object, so more maybe for text. So in this case, we want to compare basically for like a standard object of the vehicle. That is why this data set was used.
Let's go to the fourth presentation with the Abdullah Singh Sharma. How come do you know? No? Okay, can you move my presentation after this? Okay. So, I changed the order of the presentation. So, if you present your presentation at data lip-sync. Is there data? You the guy from there. Try another one. Serene Naidu. Please. I'm sorry, we changed the order. Okay, are you ready?
Yes.
Good afternoon. My name is Serene Naidu. I'm a student manager at the University of Technology. My paper is on a data-driven approach to process control modeling using machine learning. And my co-authors are Dr. Milena Pillay and Mr. Shantanu Maharaj. To understand the critical role of process optimization, traditionally, industrial operations have relied on establishing frameworks for process optimization. However, because the landscape of process control and technology has drastically evolved over time, these advancements in machine learning and artificial technologies are now being used to enhance process optimization. Our study aims to highlight the transformative potential of these innovations in comparison to conventional optimization approaches. Having a look at some of the advancements in process control over the years, we can see that from the evolution of process control technologies, which has been primarily built around neural networks, we can also now see interconnected control loops for machines, enhanced output, use increased adoption in machine learning for optimization in non-linear control loops. However, there is an increasing still lack of confidence in incorporating machine learning into optimization processes. Common use of background propagation and neural networks in process control optimization is also currently being researched, as well as exploration of applications of deep reinforcement learning for successful flow control. So for our study, we have observed recent research emphasizing integration of machine learning into control loops, which has showcased promising results. Despite this, as I previously mentioned, there is a lingering hesitation in embracing machine learning due to the concerns and confidence. Our study, therefore, has been aiming to bridge the gap and advocating for a deeper exploration of leveraging machine learning for enhanced process optimization. So overall, for the objectives of our study, we wanted to determine which algorithm can select the most optimal features to use to produce the best quality result from a control process within a oil and gas industry. So this evaluation was done through the utilization of Python programming and specific modules. And we aim to not only optimize the process, but also to ensure a comprehensive comparison with existing optimization results. This approach laid the foundation for our study's methodology and outcomes. So to look at the methods used in the study, considering the nature of the process, which was aimed at optimize the quantitative continuous value, we selected regression algorithms. These algorithms included the decision tree regression algorithm, ridge regression, random forest regression, and support vector regression. These were evaluated against a baseline of linear regression. This choice was based on historical data available and was necessary to align with the algorithms with the specific characteristics of the process. It's also important to highlight the importance of data alignment with the algorithms chosen for the effective optimization process. In order to evaluate the effectiveness of the study, the following evaluation metrics we used, which was R-squared as well as mean squared error. To ensure unbiased results, we also used k-fold cross-validation with a k-fold cross-validation of 5. This ensured that we prevented bias and validated the robustness of the model. These metrics became our guiding benchmarks, influencing the decisions that we made subsequently in selecting the most effective algorithm. So our study relied heavily on data analysis and pre-processing. The data provided to us consisted of randomized historical data from 2014 and 2015, including lab samples and process equipment information. However, for confidentiality reasons, certain process variables and certain aspects of the data were masked. Pre-processing was quite important here to remove the outliers and corrupted values arising from various control system errors in the process environment from which the data came from. These were all removed to ensure that we have reliable data for our model development. So when it comes to the model selection, we subjected our chosen algorithms to comprehensive testing. Our focus was to determine best performing models based on the R-squared and the mean squared error. The decision tree regression algorithm and the random forest regression algorithm emerged as the top performers, showcasing the best results. This was quite surprising to us, but we were prompted to explore this further. So as you can see from this graph, This indicated why we chose decision tree and random forest regression, as they perform significantly better than the other regressions, as well as the baseline regression. Okay, as we proceeded to our next step, which involved defining and optimizing the models, we adopted a split of 80% of the data for model training and 20% for validation. This optimization process comprised of extracting the crucial features, doing hyperparameter tuning, and synthesizing best performing parameters. Our feature selection highlighted commonalities and distinctions in feature importance for each model. This phase allowed us to visualize the key influences in our process optimization, enhancing our understanding of which features were most critical in the overall process as per each model. So my next slide shows you the hyperparameter tuning values that we ended up using for the two models that we chose to evaluate further. And my next slide also visualizes the differences and similarities between the features of most importance for each algorithm. So when we look at the results, the random forest regression model surpassed initial expectations and outperformed the decision tree model. This was unexpected and because due to the initial R-squared as previously saw, and the optimized random forest model exhibited significant improvement. The R-squared value improved by 58% compared to the existing production model. Additionally, the mean squared error fell to 0.435, indicating a substantial improvement in predictive accuracy compared to the previous range of the existing production model, which was 0.72 to 1.1. And as you can see by this graph, we can look at the difference between the actual performance versus the predicted values. And as previously mentioned, the average R-squared and the improved mean squared error. Okay. And in conclusion, our study illuminated the potential of machine learning in process optimization, affirming the transformative impact on industry practices. It emphasized the crucial role of data engineering and model evaluation and feature selection in driving improved performance. Furthermore, the speed and resource efficiency demonstrated by the methodology further affirmed the importance of machine learning in future enhancements of process control, namely by having more accessible technology available, which can enable more inclusive engagement of engineers and optimization. Beyond our status scope, the findings also indicate the potential wider industrial applications. Having machine learning techniques opens doors for greater collaboration between industry specialists as well as engineers, and the reduced time in model development by having these open source technologies available allows for more comprehensive testing and refinement of variables that influence plant optimization. So, underlying this, we have definitely found that looking ahead, the prospects of implementing similar methodologies on larger data sets and broader process variables all promise for the evolution of process optimization as a whole outside of the traditional frameworks currently employed by various organizations. So just here are some of the key papers that I referenced. More can be found in the additional paper. And for more information, please contact me. And thank you very much.
Any questions? So you made a hyperparameter tuning. If possible, could you tell us how did you tune?
So I used the standard variables that were suggested by the typical process originally defined in the documentation provided. And based off of that, I started to adjust the values in the model. So some of the hyperparameters were, for example, the number of samples used. So then I would increase and decrease and just observe how they change and how it affects the model.
So you survey every combination of the parameters?
No, not every combination, but I will include it in the loop so that it would choose a different value.
Okay. Okay. Okay, great.
When you go to the graph, no, the one that showed the actual prediction, what's the story there behind this fact that is critical compared to the other parts? Between 30 and 40.
Yes, so remember this is actual process data from a plant in Africa. So there were a lot of factors outside of our control, but this was a significant improvement of what the previous model had predicted. So although there is a spike, this shows still it was improved based on what was previously predicted. I think in the future I can also include the previous prediction for a greater comparison as maybe the means with error also does not have that clear enough today.
I thought that there was something in today's because you see that it's a big gap compared to all the other parts. So I thought maybe it was an expression that was actually in this situation.
Could be. This was a chemical process in a very volatile environment. So there were a lot of outliers that we had to cleanse out. We also consulted heavily with some of the chemical engineers and process operators to see what data was actually feasible and what was not. So we did try to regulate the process as much as possible. But of course, in the real world, there will always be so much volatility. So although we cannot have the because it's still the early days of the experiments, we will not have a completely smooth and accurate trend as yet, but that is something that we would like to work on further improving and advancing.
Okay, time is up. Okay, thanks so much.
Thank you, Madam, for meeting.
Are you ready? Okay.
deep learning approaches. Here is my outlines. We will talk about abstract and then why we're using this research and some type of brain tumor and then some previous research. Also, we will talk about methodology and what the data set we use and the experimental results and conclusion. Here is the abstract. Actually, our work, we use Scratch built in deep learning and some artificial using transfer learning. These models all stack together, and then we are using logistic recognition to classify these classes of or brain tumors of detection. Here we the first three classifiers, PG16 and PG19 and ICECET architectures we're using as Scratch development. We combine with the last two classifiers for architectures, BioNet V2 and Reception ReachNet V2, and then we stack together and we get results. Also, we training and testing each architecture individually. And the experimental results, we got between 99.5% to 100%, so some cases 100%, some cases less than 100% in accuracy. And also in precision, we call F1 score. Introduction. Actually, as we know, the brain is important in this research and it's a hot topic in the area because it's important topic. And also, the brain tumor occur in around 250,000 people a year globally. And tumor segmentation is, most of cases, is difficult to detect the image, specifically in medical images. Also, classification of tumor detection as tumor or non-tumor. Some researchers, they use in the tumor some classes. So we have some type of tumor, and then the last class is non-tumor. Motivation. So here, why we use this research? We're using to detect brain tumor early, and also reducing pressure of human judgment in the tumor images. Also reducing the death rate by detection, of course, by early detection. Also, extend supporting faster communication, so the patient care can early or care remotely. Also, we have the deep learning methods usually get better results than standard techniques. Here is the types of brain tumors. Some of these types, of course, there is many types of tumor, but here we use in this research just 3 classes, and the fourth class is non-tumor. The first one, meninoma, is the most common primary brain tumor. It is accounting for more than 30% of all brain of tumors. And also we have glioma, is the primary tumor in this detection. And the last, the third one, pituitary, is not actually always a tumor, but it can be benign because it doesn't spread to all the body of or to the parts of the body. So this is the type of tumor, and non-tumor. This is samples from our data set. Here is previous research. First one in 20. There is many previous research, but I choose these 3. The first one in 2023, they proposed parallel deep CNN topology to extract global and local features, and they got 97% and 9760 and 980.12 respectively, and of course binary dataset and multi-classes dataset. And the second one models of CNN. It's called efficient net. They have three members: efficient net B2, efficient net B3, and efficient B4, and they got 95 to 99.5. This is the closest research to our results. And also 20 in 19, they proposed also deep learning, but combining average pooling and max pooling layers along with one-by-one kernels. They used dataset class 2013. They got these results 80 and 71 and 71 in the three cases. Here our methodology or proposed work. First we have the data set, and then the data set get image processing, such as reduce the size of images and other stuff to process the image to input to the deep learning. We have 5 architecture of the deep learning. After we train these models, we got these 5 models together, stacked, to get new training set, and then we train this data set, and we combine together, and then we got testing the data set. We got brain-tumor and non-tumor. So we did 2 cases of the evaluation for binary classification and multi-class classification. Here is the hyperparameters we use in this architectures. We have like by size, we use different by size, and also we have learning rate, regularization strength, and evoke 300 to 1000. Of course, this is we cannot run it in my computer or laptop, so we use server. It's called like Google Colab or Paperspace. So they have GPU is powerful, so and the speeding is very fast. So we can finish 1000 or more if you want. But it depends what the subscription you use or how much you pay. You get more space and more speed. Here is the data set we use. First data set, we have 2 different data sets. First data set, we use it in this paper, this reference number 7. We have binary classes, brain tumor, non-tumor. We use 3,000 images. Brain tumor 1,645 and non-tumor 1,355. And also we use the other data set, multi-classes. We use different data sets. We have 4 classes. The total 7,023,000 of images, like glioma 1,330, mini glioma 1,642, pituitary 2,042, nodoma 2,009. So this is the 2 data sets we use in our methodology of evaluation. This is the data set for our experimental results, such as the first 3. We use scratch n, the results, and the last one and below is for transfer learning. So as we see, the first 3 is higher than the last 2 because transfer learning learn from different data sets. So that's why we get a little bit low the results. This is results for binary classification. And the other one for multi-classes, the same way, we have 5 architectures. As we see, the first 3 is the better in accuracy or loose. Here is the results for compare between the 5 architectures and between the stacking, for example, transfer. This is binary classes, and the other one is multi-classes. As we see, a little bit more better than the other architectures when we stack these architectures. Here we compare our results with other researches. We have all these researches. Number 16 is the closest one of a result from our results. Our approach in binary classes 100%, so easy for the model and the other one is 99.95. And also the multi-classes, we make it 2 classes and we find the 2 data sets and then did the same methodology. We get these results. So it will be good for real world. For conclusion, this is our, as we said, brain tumor is important for medical problem to detection the tumor, and also the deep learning usually showing good results in images, specifically in the medical images. And we use 5 pictures. And then in the future work, we plan to detect more types of tumor brain. And also we can use unsupervised, we can combine together, or using deep learning application and combine as one picture and using machine learning. So it will be maybe good results than this. So that's it. This is the reference. You can, if you want to look at it. And thank you.
Any question?
Yeah, okay. Does the size of the scar and the thickness of the scar affect the accuracy of your algorithm?
The data set?
The size of the scar and the thickness of the scar affect the accuracy of your algorithm.
The size of the
scar, of the head.
The size 225 by 225.
Yeah, but that's the size of the scar.
I tried one, it depends in the pictures, in the image. So you crop the image, I tried 128, but 225 is better the results, better than one. But the speed and time is less. But the accuracy is more when you're using more image, because it takes more features.
Please from the behind. Yeah.
My question is on the data. How do you collect the data?
How
the data that you use for research? How do you collect?
The data set, you mean the deep learning or data set?
The data
set from previous work. I used the data set already there. They published already.
Okay.
I didn't create it. Someone did it. So I used different data sets and then combined together.
Because I'm asking because I'm looking at one, the nature of the test itself. Wise and one and 2 on your
You mean this data sets?
Yes.
Yeah, this is data set. The reference number 7 is the paper they publish it. I use this data set. Same these images. They use these images.
Okay. That's
they take picture from brain. And they make
look to the next.
Did you use retrained models? Or have you trained the models used in your multi-network architecture?
I use 2 types of models. One scratch code, and I did it, created, and one is transfer learning. It's already there, pre-trained. So it's pre-trained from different images, not from a training. That's why the accuracy is less than when I.
Why did you use 2 different data sets for the binary classification?
To compare the transfer and scratch paste and show how we combine how the results.
Okay, thanks so much. Okay, yes, please. Okay, go to the data sheet. Okay, great.
Evening, everyone. My name is Jason Lipschitz. I'm presenting on behalf of my co-authors Suzanne Satsky and Linda Spark on our paper, Smart and Safe Driving, a review of threats and security measures for autonomous vehicles. So I think over the course of today we'll see just how rapidly IT technologies are advancing in the world across industries from agriculture and education all the way to banking and financial services. One area which I've seen particular interest in the public is that of autonomous vehicles, which have been driven by this rapidly advancing revolution of IT technologies. Recent estimates have predicted growth rates up to 53.6% every year until 2030 to reach close to 3.2 million active units of autonomous vehicles. And with this, we're beginning to seriously see how autonomous vehicles are disrupting the personal vehicle market. As these technologies have entered the limelight, serious questions have begun arising over safety issues of autonomous vehicles, particularly in their ability to safeguard personal private data and operate at all times. So the initiation of the study drew on regulations ethical guidelines for developing energy design technologies, particularly that users' rights to privacy, integrity, and availability to their assets must be safeguarded at all times. As autonomous vehicles are considered IT technologies, leveraging sensor input and smart object recognition, allowing for task autonomy, these technologies do provide benefits such as preventing collisions, increasing fuel efficiency, and obviously offering great user convenience. The outcome of tests and functionality of it can obviously lead to very significant safety risks. So the initial review of relevant literature found that although there are many studies focusing on individual security threats and developed security protection mechanisms, there's very little literature detailing a systematically collated view of these topics. Therefore, the aim of this paper was to inform manufacturers, researchers, and potential users on security threats and countermeasures, so that consumers can be made aware of the degrees to which they are protected. And researchers and manufacturers will have knowledge base upon which to build on and consult. Consequently, the main research question for the study that we developed was what is current literature on autonomous vehicle technology report and discuss in regards to threats and methods of protection in the time of cybersecurity. And from this, we did sub-questions of what are the different technologies used in autonomous vehicles, what are the primary threats, security threats associated with autonomous vehicles, and which technologies and processes are currently being used to protect autonomous vehicles. So we conducted a systematic literature review with our keywords and inclusion criteria and research numerous databases. We then screened and assessed the quality of the found papers, resulting in 15 papers available for the review. We conducted a systematic, we conducted a qualitative content analysis on each paper. The codes were initially derived from our research questions, and then we deductively and iteratively refined these as we went along reviewing, and this helped us in making the findings repeatable and making them directly related to our research question. So to understand how threats may arise and what parts of the system might be targeted, we looked at the technologies used in AVs, which commonly include sensors, the AV canvas, VA nets, and roadside units. And so we discussed each of these. So firstly, to control speed and maneuvering operations independently of humans, AVs utilize a range of these embedded sensors. Some of the commonly used ones include LiDAR, radar, sonar, optical cameras, and GNSS to collect environmental data. So these sensors, along with the vehicle operation units, use the control area network and control area network to view, to process, and communicate the data collected to assist in autonomy. In addition, vehicle-to-vehicle communication is currently in development in the form of vehicular ad hoc networks, or VA nets, where AVs actually travel in close range platoons, sharing collected information, including obstacles and location data, absorbs any control data such as speed, acceleration, braking, and steering. And this allows for a few benefits, including effective fuel management strategies through cooperative adaptive cruise control and reducing collision probabilities. Vehicle integrated communication has also been proposed to complement this in the form of roadside units, which are just stationary IoT devices that collect traffic data and transmit information for self-driving cars during transit, such as routing data and auxiliary functions like diagnostics and entertainment. So in regards to the threats to autonomous vehicles, what we found is that there are potentially disastrous effects on passengers if security is breached. There was a controlled attack conducted in 2015 where an AV was brought to a full stop on an American highway by attackers who made use of security weaknesses in the vehicle's onboard entertainment system, and they found a back door to the vehicle's braking controls. And then in 2019, attacks were conducted on a already broken down and written off self-driving Tesla, and they found that large quantities of carbon data were still accessible. So we've put together some categorizations for different attacks that have been proposed, and this just helps break down the complexities of attacks targeting autonomous vehicles. So at the application layer, attacks target individual vehicles' vulnerabilities in software services, such as crash prevention, parking, cruise control. And the OS layer, the attacks are targeting OS services. We then have the CAN layer, which is the control layer and the code layer, where attacks gain access to available ports on the devices connected to the CAN device, and this can compromise control units. Onboard diagnostics, or OBDs, ports are particularly vulnerable at this layer, offer variable protection in the access control mechanisms, or their data encryption procedures for physically connected devices on traditional OBD ports. And then at the vehicle to everything layer, attacks target communication channels between VNets and RSUs. What we have seen though is, since the CAN and the vehicle to everything layer do share many vulnerabilities and they are certain communication channels, they can just be treated as a single network layer. And then finally, the physical layer, we look at targets, attacks targeting sensor receivers. So in regards to some of the common attacks that are being investigated, we can look at your traditional DOS and code injection attacks, which just exploit open network ports and also research systems such as onboard entertainment. What makes it quite unique with autonomous vehicles though is that there are a lot more zero days because we have, like I said, a much larger variety of technologies being used in the form of the CAN bus or VNets. They're also particularly vulnerable to eavesdropping at both parts of the network layer. So malicious actors can't only steal personal user data, but they can also steal key operational and network information, including driving instructions, sensor input, and device authentication credentials, which can obviously lead to laying the foundation for more harmful attacks. And similarly to this, Ethernet traffic attacks can also allow attackers to steal or redirect traffic to their own malicious node. And then beyond this, spoofing attacks can occur where valid but harmful messages are sent to CAN nodes, including setting braking or maneuvering devices to sleep. And then during a masquerading attack, malicious devices can disguise themselves as authentic nodes, which can lay the foundation for further eavesdropping or code injection attacks. And then since intercepted authentication messages can be used to impersonate new nodes, this attack can then be iteratively executed. And then finally, there are a few threats aimed specifically at vulnerabilities present in AVs. Firstly, we have replay attacks. And then here, these can occur where messages sent along VNet or CAN are stored and then after a short delay are then resent, which can obviously impair the system's ability to function in real time. We also have service hijacking, where specific services of the operating system are manipulated by an attacker. We also have timing attacks, where delays are just introduced into valid messages, which again will affect the vehicle's ability to function in real time. We have bogus information attacks, where fake roadwork or collision data is sent to a VNet. And similarly to this, we have cyber attacks, where if a malicious actor has access to valid authentication details, they can then declare themselves as multiple vehicles on the network, which can obviously lead to collisions with the surroundings. And finally, we have over-the-air update attacks. Since some manufacturers might have unsecured channels, any vehicle that makes use of OTA updates might have embedded code injected in. So the variety of potential threats demonstrates us that although there might be numerous benefits around these technologies, there are definitely significant risks to using them. And so we must make users aware that they must approach the sacrifice of full digital control with a fair level of caution. So in regards to some of the security measures, autonomous vehicles rely heavily on highly secure message authentication, obviously, and reliable intrusion detection systems. So threats such as masquerading, eavesdropping, code injection, and replay attacks can really only occur when messages are not properly encrypted, authenticated. And so we just need to make sure that we use strong industry standard encryption and authentication processes to combat these attacks. What has been proposed is that since AVs do have limited computational resources, at least at the moment, we should be using larger authentication processes, and a few have been proposed. One such is where authentication code is actually transmitted as fractional parts embedded in multiple data packets and then reconstructed alongside the message. And by doing this, data packets cannot actually be modified without removing the authentication code itself. And then the other okay, so let me just use IDS, and we can use IDS in tandem with the mobility of the vehicle and the sensor input in order to fact check data that is valid and not malicious. Okay. So to conclude, although there's definitely numerous benefits to AVs, potential catastrophic effects on user safety and privacy demonstrates the necessity of very highly reliable and secure countermeasures. It's essential that various technologies and multiple layers are well understood, that complexities and associated security issues can be addressed, and traditional security technologies alone are not sufficient for preventing attacks. Just in regard quickly to some limitations in future studies, although we were comprehensive in our reviews, it is possible that some studies may be missed, and we only considered English papers and those within our search dates, which was already last year. And in regards to some future work, where to from here, since the field will only continue to rapidly advance, future research is needed to understand more about the emerging threats and the right ultimate teams to make AVs safe. Thank you.
Any questions?
Thank you for the presentation. What I want to ask is about risk levels for the different types of networks you were looking at. So in the literature, do they go into much detail about what are the risk levels that they identify and which networks are most affected by those? So with bandit, for example, that tends to be like inter-vehicular comms. Now, is that going to be like a lower risk factor? So if a car says it's kind of slowing down, it's the head of the other slowing down. Is that, if it's a fake message, is it going to be a serious problem or not? But if it is within like a CAN bus, for example, and it says put on brakes, maybe that's quite a catastrophic risk.
For sure. I think most of the literature at the moment is actually, ironically enough, covering VNets, even though it's still very much in development. What we have seen currently is, what I didn't really get into the paper is the different kind of levels of autonomy within vehicles. Currently we aren't at the state where they just have full control where they go. We have restrictions on what is currently allowed. So I think for what does exist, vehicles are allowed to drive at a certain speed. So what we've seen is definitely that VNets are much more covered in that, and in terms of the literature. And so it seems like people are more concerned about VNet security, especially considering that's where malicious actors can more easily access and authenticate themselves when they are false.
Yeah, that answers it.
Today I'm presenting my paper, I'm a PhD candidate, a paper titled Financing Detection Accuracy in Water Distribution Network Combustion and Network and water scarcity and efficient management of water resources have become critical global concern. And due to the population growth, urbanization, and climate change, water plays a vital role in delivering clean and potable water to community. However, this network face challenges, particularly from water losses caused by leakage and inadequate infrastructure. The magnitude of this problem is significant, with billions of cubic meters of water being wasted annually, according to accounting for approximately 5% of to 50 of water distribution network. And water utility worldwide lose around $14 billion annually due to the leaks. And South Africa loses about 9.9 billion yearly from water leaks. Studies predict a looming water crisis with 33% of the global population with 45 countries facing scarcity by 2025. You can see this picture here shows different countries which will face scarcity, water scarcity in by 2025. Previously, researchers developed algorithms to address the problem at the end. However, this algorithm suffered from several limitations, including the need of time consuming and resource intensive manual inspections, inaccurate leak detection, and fault alarms, and randomly placed sensors in water distribution network. Detecting and locating background leaks in water distribution network is especially difficult as they are often constant. So this paper actually presents proposed in ensemble machine learning algorithm
algorithm, support vector machine, conventional neural network, and graph theory. And we named the algorithm CVM, CNN, and GT. The paper introduced innovation methods for water leakage detection in water distribution network, employing automatic features, inspection, and heterogeneous dual classifier. And how proposed algorithm SVM CNN represents an improved machine learning approach to enhance classification accuracy and reduce learning time. We implement optimal learning parameters such as water pressure, flow rate, temperature, and deep information in our machine learning algorithm. To improve the location estimation and improve GT graph theory based local search algorithm with a virtual node scale is being proposed. The proposed enhanced graph theory based local search algorithm minimize distance errors, repair cost, and time benefiting. To perform fault recognition and location identification, the proposed method utilizes various sensors, including pressure sensors, vibration sensors, and flow sensors. Therefore, this adaptable approach can be applied to gas leak detection. And we previously, some researchers work on a similar research and propose different algorithms. Polo and others in 2022, they proposed a weighted sample CVM algorithm for leak detection in water distribution network to optimize accuracy and minimize the noise outlier. The algorithm outperformed methods like acoustic signal analysis, transient signal analysis, and temperature variation analysis in leak detection accuracy. Our proposed algorithm, CVM, CNN, GT algorithm shares similarities. But improve upon their approach by considering optimal sensor placement, optimizing detection, and reducing costs. Their algorithm sets itself apart from their approach of randomly passing sensors. And another research in 2022 proposed a leak detection algorithm in which it combined different algorithms, kernel principal component analysis, and support data description. And however, their method overlooked the importance of minimizing business errors, resulting in delayed leak repairs and high costs. And if inefficient leak localization might necessitate multiple attempts for accurate detection, increase excavation, repair, and maintenance expenses. And another researchers proposed an algorithm and which they use HAPNet to simulate their proposed algorithm. HAPNet actually is a software, is a hydraulic software model and water quality behavior, water distribution piping systems. And the proposed leak detection and architecture, we propose the leak detection algorithm. We have different sensors which will be mounted on a pipeline, which will detect the leakage and collecting the information and send via IoT gateway, and then the information will be saved on the cloud, and then we have here the controller, the user will control the data and to locate the leakage. And graph theory optimize sensor placement in water distribution network, optimize leak detection costs, reduce and environment impacts, minimize and small dominating self-identifier, optimize monitoring nodes and optimize placement efficiency. And support vector machines. Algorithm is primarily used for pattern recognition and classification tasks, as illustrated in this figure here. The support vector machine algorithm have been employed to detect and predict water losses caused by the leak by analyzing various data variables such as water pressure, flow rates, temperature, and information into the CDM algorithm accurately predict the location and veracity of leak in water distribution network. The objective is to find optimal hyperplane that effectively discriminates instances with leaks from those without leaks, and this is achieved by minimizing. We propose some algorithm equations, mathematical equations to solve to optimize some of the conventional neural network, CNN, was also used. This model consists of layers dedicated to processing, enabling the learning of diverse input data features such as images and multiple levels of abstractions, as the figure here shows above.
Sorry, computation. So if you have some results, please show that.
We have this our data, and this is our model, simulation result model, network, and this figure here will shows that this node 5 is a critical node which we need to pay attention on this node, and we have also this node 40 here, which we might minimize the pressure to control control the leakage. And accuracy of the leak detection, we compare our proposed algorithm with the previous ones, which is we compare the CVM, CNN, CT with against the CVM and the CNN. And we can see our algorithm here improving in leak detection accuracy. Our algorithm improved accurate detection accuracy of 98%, followed by the CVM, which is 82% and 48%. So, conclusion, this paper actually proposed the CPM, CNN, GT algorithm to optimize the detection accuracy and optimize sensor clustering for cost, for this sake of costs, installing less sensors, still keep the quality of service, and thank you.
Okay, I'm sorry, we have a time limitation, but any questions? Okay, please. Yes.
Thank you. Spend more time. Now my question is,
okay,
you develop an example model that combines support CNN and graph last model. What's the name of that? Graph
theory model.
Graph theory. My worry is, why support vector machine at the beginning of the fourth diagnosis pipeline? To my understanding, convolutional neural network does feature extraction. So how does this support vector machine connect to the convolutional neural network? What is its function in the fourth diagnosis pipeline?
So, thank you for your question. So, actually, we combine the strengths of each algorithm because they are not working, they are working differently. So, we combine the strengths of each algorithm, and because each algorithm have a specific strengths to optimize the proposal.
Not very clear. Now, I will support vector machines to be classified one and those classification. So my worry is, why is it at the beginning of the fourth diagnosis pipeline? Because if you want that does the classification between the efforts, because your model is a classifier to classify whether something is leaking in the model. Now support vector machines appear at the beginning of the pipeline. They will have convolutional neural network to be neutral and then graph chain. So I don't understand how support vector machines connected to the same. I don't know that you can do this.
Let me rephrase what I said. Support vector machine algorithm has been employed here to detect and predict water losses caused by leak by analyzing various data variables, and such as water, flow rates, temperature, and leak information. Support vector machine accurately predicted the location severity of leak in water distribution network. So the objective is to find the hyperplane that effectively discriminates instance with leak from those without leak. This is achieved by minimizing, we will had some algorithm, while CVN is working differently with different trends. And the graph theory will allocate the different sensors on on the network.
Okay. Okay, so maybe offline you can discuss. Okay, thank you very much. If there are some here to watch, I will. So, yeah, this session has extra presentation. So, you will two presentations?
Yes, two.
Yeah.
I'll be very snap. I know we're all tired.
Okay, thank you for your cooperation. So, the two presentations are different.
Yeah.
Okay. I don't know the background, but yeah, this presentation, yeah.
All right.
Okay, please.
I'm presenting a paper on the hybrid empirical mode composition support vector machine for multi-fault recognition with mid-to-band gearbox. Okay. Wind energy offers a promising solution to the global energy crisis. According to IRENA, it accounted for 21% of the global renewable energy sources in 2022. However, the frequent failure of wind-to-band components have limited the spread. The operational and maintenance cost of a new wind-to-band accounts for 20% of the total levelized cost by global units over the lifetime of the wind-to-band, and a significant proportion of this cost is incurred by the maintenance of the wind-to-band gearbox, which accounts for 21% of the failure of wind-to-band components. 6.1. Now, to prevent the catastrophic failure of wind-to-band components are typically monitored using machine learning models. Usually, we collect data. Sensors are mounted on the wind-to-band component to collect data. Data is analyzed using machine learning models to predict when there is an imminent fault in the wind-to-band components that can be arrested before the catastrophic failure of the wind-to-band component. Speaker data employed include SCADA to bind conditional routine data such as vibration and acoustics. Recently, the use of vibration signals for fault diagnosis wind-to-band components are gathered the result of without attention. Benefits of vibration when you derive from the fact that it is non-invasive, cost-effective, and makes for any fault detection. A traditional fault diagnosis process using vibration signals, the signals are usually time domain features are usually extracted from the vibration waveform and given directly to machine learning model to classify different fault states in the gearbox components. However, this approach has a number of limitations. Primarily, the features extracted are not sufficiently discriminating to distinguish between the various fault classes. And this is primarily due to the complex nature of vibration signals from the wind-to-band gearbox. To solve this problem, we propose an advanced signal processing technique called empirical mode decomposition. So we use empirical mode decomposition to pre-process the signal before extracting features from it to give to the machine learning model. Empirical mode decomposition is an adaptive time-space multi-resolution method employed to decompose non-linear and non-stationary signals into physically linear meaningful components called intrinsic mode functions. The strengths of EMD includes its ease of application, robustness, and superior performance on non-linear, non-stationary signals like vibration. Here's our methodology. The vibration signal is segmented into equal window bits, and from each window,
we decompose the signals into IMF using empirical mode decomposition. Statistical features are extracted from each IMF and then given to the machine learning model. In our study, we use the support vector machine. Support vector machine then does the final classification of the first piece. This is a basic theory of a support vector machine. I don't need to go into details about it. The objective of our studies is to develop a fault diagnostic models for multi-fault recognition in a gearbox, to investigate the effect of the empirical mode decomposition validation window on the performance of the support vector machine. Remember the EMD divide the signal into different windows before performing EMD. So we want to find out the effect of the window size on the quantities of features extracted from empirical mode decomposition as evidenced by the performance of the downstream classifier. Also want to investigate the effect of the kernel on the performance and computational time of the support vector machine. The data we used was sourced from the National Renewable Energy Laboratory. It was divided into training, 70% training, 20% validation, and 10% testing. These are the parameters of the support vector machine we use. The most important parameter is the kernel. We try to investigate different kernels, including radial basic function kernel, linear kernel, polynomial kernel, and sigmoid kernel. The important result is presented in this graph. This graph, we want to see the effect of the size of the empirical mode decomposition window on the quality of features extracted as evidenced by the performance of the support vector machine models. The window size must be large enough to capture the most important signals. It must not be so large as to include redundant information, therefore decreasing the performance of the downstream machine learning model. From this graph, we see that as the vibration window size increased from 1,000 to 500,000 samples. The downstream SVM model maintained constant peak performance scores. However, beyond 500,000 samples, its SVM model performance begins to decline. Looking at the training time, we see that training time maintained a constant decline with increasing EMD window size. So from this graph, we summarize that 500,000 samples is the best window size for the current data set, as the downstream SVM model perform optimally while requiring the least amount of training time. So in this table we compare the performance of the SVM developed from different kernels. So we see that the use of both sigmoid and radial basic kernels all perform well. But the radial basis function kernel require the least amount of training time, making it the choices for the study data. So in conclusion, in this study we presented an empirical mode decomposition method combining the support vector machine for multiple recognition in unit-to-bind gearbox. The major takeaway are that the EMD window size impacts the quality of features extracted. The optimal EMD window size of 500,000 samples. The choice of kernel function also impacts the computational time and performance of the SVM model. The radial basis function kernel was the choices for the study data as it gave the optimal classification result while requiring minimum training time. The high performance of the models made them suitable for use as diagnosis tools for unit-to-bind gearboxes, allowing precise fault diagnosis with minimum classification errors. Thank you very much.
Okay, thanks so much. I think
should I go to the next paper?
Next one.
Okay.
Okay.
Right, here we go. Okay. My next paper, hyperparameter. Okay. Alright, here we go. This paper is titled Hyperparameter Optimization on CNN using hyperband for fault diagnosis in wind-to-bind high-speed shaft bearing. In this study, the problem statement is almost the same with the previous one. However, we're using a different method to solve the problem. And our emphasis here is not the entire gearbox, we are concentrating on the high-speed shaft bearing. If you see that figure there, that's the location of the high-speed shaft bearing in a wind-turbine gearbox. So we want to see how we can use CNN to optimize the hyperband to optimize the parameters of the CNN for diagnosis in the wind-turbine high-speed shaft bearing. So these are the failure statistics for critical wind-turbine components. From that graph, you see that the high-speed shaft bearing accounts for 48% of the failure of wind-turbine gearbox. So, yes, in a typical fault diagnosis, we extract features from the time domain signal from the vibration waveform and give them to the machine learning model. We already stated the limitations of traditional fault diagnosis. So in this study, we propose the use of deep neural network. In traditional machine learning, features are extracted from the machine learning model and then given to from the vibration signals and then given to a machine learning model. But in deep learning, we do not perform feature extraction. The process is end-to-end. It does not require for feature extraction and results in high diagnosis accuracy. The one critical requirement of neural networks, as it is with all black box models, that they require hyperparameter tuning. In this case, we are using the CNN model, so we are proposing a method of tuning the hyperparameters of the CNN model. Hyperparameter tuning iteratively adjusts the parameters of the model to find the optimal combination that maximizes the model's accuracy and other parameters. It's an attempt to find the sweet spots that balances between overfitting and underfitting. In this study, we propose hyperband for hyperparameter optimization. So these are methodology. We are using in CNN, the vibration signal is a one-dimensional signal. So it needs to be converted into a 2D matrix before giving to the CNN model, because CNN work with image data. So hyperparameter optimization with hyperband. Hyperband is a bandit-based multi-fidelity optimization technique that extends the successive halving algorithm. Successive halving assigns resources, including data samples, iterations, or some features from a field budget to each of several different hyperparameter configurations, evaluates their relative performances, and eliminates the worst half. The strength of hyperband includes that the algorithm is theoretically sound, it is simple, adaptable, and employs an early stopping strategy. So these are the steps we follow to perform hyperparameter optimization with hyperband. We provide the CNN parameter ranges with hyperband algorithm. These include the activation function, the learning rate, the number of features, and the dropout rate. Range of parameters are provided to the hyperband algorithm. They will specify the value of R and mu, where R is the maximum quantity of resources that can be assigned to an individual configuration, and mu is the fraction of configuration eliminated in each iteration of successful halving. You compute the value of S. S is 0, successful halving is complete. Otherwise, successful halving is performed, and the cycle continues on the S is 0. At this junction, the final model parameters are compiled from the global optimum value. So these are the important results of our studies. We see the optimal hyperparameters for the CNN model, the activation function, the best activation function was the exponential linear unit, learning rate 0.01, number of filters 16, the dropout rate 0.25. In the next table, we present the parameters of the optimal, the architecture of the optimal CNN model. In this table, we compare the performance of our standalone model with the optimized model. From this table, we see that the important metrics of the CNN model improved with hyperparameter optimization. The accuracy increased by 13%, sensitivity increased by 29% after hyperparameter optimization, specificity increased by 16%, and F1 score increased by 18% after hyperparameter optimization. In this graph,
we compare the two models, the optimized and the standalone model, and we receive a pretty characteristic curve. In this curve, you see that the optimized model had an AUC of 1.0, while the standalone model had an AUC area under curve of 0.97, showing that the optimized model performed better than the standalone model, demonstrating the efficacy of the hyperparameter in hyperparameter optimization. Here we present the confusion matrix, the classification confusion matrix of the standalone model and the optimized model. We see in the A part of the figure that the standalone model had 32 cases of misclassified observations, whereas the optimized model had no case of misclassified observation. In conclusion, we see the hyperparameter optimization for CNN model with hyperparameter improves its performance and robustness in fault detection from vibration signals on the wind to find high-speed shallow area. Thank you for your audience.
Okay, thank you very much.
Yeah. Can you please explain how you did the transformation from vibration signals or time-based signal to a 2D array?
Okay, all right. What we do is that the window, usually for a 32, for instance, depending on the final output of your image, if you want your image to be 32 by 32, 32 times 32 is what? So now the window size, the window length will be equal to the square of the dimension of your. So you can now, from there, you now transform it into a 2D matrix. I don't know whether you understand.
Okay.
Do you get the explanation?
Yeah.
Depending on the final image, the dimension of your final image, if it's 32 by 32, 32 times 32 is what? So that will now define the length of your window. You now window at that length, then you now perform a transformation in Python. You just transform it into a two-dimensional matrix and then provide it to your CNN model. I don't know whether you understand.
Yeah, I thought, I assumed that you made some transformation into the frequency domain.
No. It's just the time domain signal. Yes, the time domain signal. You don't need to pass through frequency domain.
Okay. Any other question? Okay, please.
How big is the feature room of the final CNN? How many parameters do you need for detecting the problem?
Depend which model are you referring to?
Parameter amount of the whole CNN model.
Okay,
How big is the model?
Okay, the CNN model. For CNN model, these are the details of the CNN model we used. Kernel size, the filters to kernel size 2 by 3, then max pooling size 2 by 2, then we had a flattened layer, a dense layer, dropout rate, and then the dense layer. These are the details of the CNN model.
Thank you.
Alright, thank you very much.
Thank you very much. Okay. So let's conclude this session. Thank you very much. No such rules. Do you take? No? Okay. Thank you for attending this session. Okay. Have a good night.
Thank you, everybody. It's finished for today. And tomorrow is all on and talking about it.
the last one.
How are you?
Yes.
It's my so how does the what explaining the commission which might has
I think this is still on.
Yeah, this people are able to the subs provider report. So, we are comfortable with the highway maintenance company. And they try to sub area, the highway should be related to the number of trucks will increase. So, because of this program, they will try to do things that finally, such will be utilized. The first purpose is service providers. Yeah. For example, after the restaurants, they go to the museum, such a window. So we provide information to the restaurant and the museum, and they will prepare some discount ticket. So finally, this service will be provided. This is our part.
I don't know if it was for example, I once said the same you guys it's a very way of trying to find out their thing so that you know what's going so far, it looks like only especially people who must be paid. You want to know
From the top, I explained it now, we should we prepare two-dimensional reports. We call it QR code. Maybe we put some information here, and probably can get such a discount information. Yes, some people have good idea.
Much previous years, but this year has been on the way that the error if you're interested in
So my background was actually computer science and information systems, so it's not really but maybe do some in-between courses, then I could still go that route. I would definitely like to pursue that as postgraduate, but it's quite a bit of a jump from one topic. I'd like to do the applications like yeah. So I'm working now on the financial course last year, working as a software engineer at they're based in Germany. Yeah, I'm just working for a couple of years and then picking up his master's. So hopefully by then I'll have skills.
What I say to, well, some of my students, those who are kind of branching very quick, I would say maybe you ought to try history for a little bit before you jump to computer. Whereas with students that are, one doesn't necessarily feel that they're prepared, maybe you should encourage them to carry on longer before they go.
I must say, it's one of those things for me, getting to paper really, we took every step leading up to it, but then when you get proper marks, we have got collaboration. So
The moment it's literally we're paying for.
Yeah. Oh, that's the reality of conferencing running babies. Good.
Well, thank you again. Yeah, nice to meet you too. Thank you very much.
Yeah.
See you. Sorry. Should have done it a long time ago. Cheers, cheers. Nice to meet you.
Cheers. Good to meet you. I'm going to come back to get this camera back.
Yes. Do you need any help with anything?